As far as the absolute value theorem goes, it's kind of a silly theorem. It says that if you've got the limit of a sub n, of the absolute value of a sub n, and that happens to go to 0 as n approaches infinity, then the limit of just regular old a sub n would also have to approach 0. This allows us to do things like when a limit's oscillating around 0, it lets you take care of that oscillating thing. So like you've got something like 1/2, and then -1/4, and then +1/8, and then -1/16. And if you take care of all of the negatives, if you just cross all these out, take the absolute value of them, you've got 1/2, 1/4, an eighth, a 16th, a 32nd, etc., etc., etc. We can see that that's going to approach 0 pretty quickly. Whereas without taking the absolute value of them, we might be a little bit more confused. Now, this doesn't work in just normal limits. If you've got the limit of just -5, that absolute value approaches 5. Doesn't mean the original thing actually approaches 5. The original thing approaches -5. So this only works when our limit of the absolute value is approaching 0. Because it doesn't matter if you are positive or negative. If you approach 0 from either side, you're still approaching 0. So that's why this one works. All right, so let's try to put some of this together and actually determine whether some of the following sequences converge or diverge. Now, if a sequence is going to converge, it just approaches a number. If it doesn't approach a number, if the limit does not exist, then it diverges. So this could be something that oscillates, or it could be infinity. So for sequences, you want to just think of them as limits for the most part. All right, so the first thing we got to realize is this notation. So this is saying that we're talking about n is going from 2 to infinity. Now, n can go from any number you want to. It can go from 2, it could go from 1, it could go from 0. We're generally going to take these going from 1 like they go in the next one unless otherwise stated. But you can start a series or a sequence at any number you'd like to. This is just a good notation to let you see. And then the upper bound would be to infinity. Well, if we're talking about this in terms of limits of just functions, well, we look at the degrees. And I've got a squared and a squared. So since the degrees match up, you look at their coefficients, 3/5. So does it converge? Yes. And it converges to 3/5. And that's all we got to do for that one. All right, well, let's think about the next one. Does this sequence converge? Well, we've got, can't really look at their degrees because the numerator is an exponential and the bottom is just the first power. Now think about just the raw size. You got e raised to something, some power. That's huge. Over just regular old n, that's not quite so huge. So we got infinity over a small infinity. So we've got a big infinity over a small infinity. And that's just logically not going to give us much. So if we want to use L'Hopital's rule, because we can treat it like a function, we could take the derivative of the top and the derivative of the bottom, but the numerator is so large, this is going to diverge. So if we wanted to be a little bit more fancy with it, we could use L'Hopital's rule, which would be e to the 2n over 1, which is going to go to infinity over 1, which is infinity. So for the most part, we can just look at these as limits. All right, let's see what else we got. All right, so for C, if we start plugging in numbers for n, you're going to see this -1 to the n deal quite a bit in the near future. And let's see what happens to that. So if I was just to plug in numbers, so -1 to the first would be -1 over 1. And then I plug in 2 would be my next one. -1 squared would be a +1 over 2. And then if I plug in 3, negative to an odd number would be a negative over 3. So we see pretty quickly that -1 to the n, you got to make sure that the parentheses around the negative, because in other words, it's just 1 to the n and a negative out front of that. So this is going to alternate. Next one's going to be a +1/4, and the next one will be a -1/5, etc., etc., etc. So we've got this alternating deal. But what are the numbers approaching? You got 1, you got 0.5, you got 0.3 repeating, 0.25, you got 0.2. The number's getting smaller and smaller and smaller. So what we're going to do, hoping most of us probably see this by now. If we look at the absolute value limit of the absolute value of -1 to the n over n, well, this would be equal to the limit of 1 over n, which 1 over n, that's just going to go to 0. So since the absolute value equals 0, this whole thing equals 0 by the absolute value theorem. All right. So the absolute value theorem, I mean, I could say it by the absolute value theorem. But for the most part, a lot of these problems are going to be multiple choice problems where you're just going to tell me what the limit is going to be. We want to be able to do this in notes and tell me why, but in general, it's a little bit more gut instinct logic that you want to use on these. All right, well, can we use the absolute value theorem for part D? Well, the absolute value of -1 to the n is +1. The absolute value theorem only works for 0, so that doesn't work. So what are we going to get? Well, we got to be careful if we write these numbers out. So -1 to the 0, because we're starting at 0, would be a +1. And then the next one would be a -1, and then the next one would be a +1, and the next one would be -1. So this is just going to bounce back between +1, -1, +1, -1. It's never going to settle down. It's going to oscillate between the two numbers. I mean, if you looked at the graph, it would just kind of like look like this, which doesn't look like a limit of any sort that I can tell. So this one's going to diverge. And there's a lot of different types, and if you're not very good at your limits, well, the good news is you get to practice them in this lesson. Let's see, is there anything else on here? Alright, so the last thing that I've included for you guys in here is just a little bit of a website that has some more explanations on this. I thought was pretty good. So check it out if you would like to. Other words, good luck.